Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of line in R3. So as per the problem, state the coordinates of a point and a direction vector for each line. So let's start with the first line. Now in this equation, this part of the equation is written in symmetric form. The y equation is written in parametric form because the y component of the direction vector of this line is 0. Let's start by writing general equation of a line in symmetric form. The equation is in this equation a, b and c cannot be equal to 0. In the given equation, the y component of the direction vector is 0. That is why the y part of the equation is not in symmetric form. We can rewrite the y equation as now we can write the coordinates of a point that lie on this given line. In the symmetric equation, x naught, y naught and z naught represent the components of position vector of a known point on this line. So in the given equation, x naught is equal to -2 because numerator in the x part of the equation is x plus 2. Y naught is the number term in this y equation, which is -3. Z naught is equal to 1. So the coordinates of a point that lie on this line is -2, -3, 1. Now we can find the direction vector of this line. Now since the x and the z part of the equation is given in symmetric form, the x and z components of the direction vector are in the denominator. The x component of the direction vector is -1. The y component of the direction vector is 0. But as I mentioned earlier, the y part of the equation is not written in symmetric form because the y component of the direction vector is 0. And the z component of the direction vector is 2, the denominator in the z part of the equation. This is the direction vector of the first line. So we are done with part A. Now we can analyze the second given line. The second given line is in parametric form. X equals 3, y equals -2, z equals -1 plus 2k. There are no k terms in x and y equations. That means the coefficient of k terms in x and y equations is 0. We can rewrite the x, y and z equations as so these are the parametric equations for the second line. Now we can find coordinates of a point that lies on this line. The coordinates are the number terms in these parametric equations. So in the x equation, the number term is 3. In the y equation, the number term is -2. In the z equation, the number term is -1. So a point on this line is 3, -2, negative 1. Now we can find the direction vector of this line, and the components of the direction vector are the coefficients of the k terms in these equations. K is the parameter in these parametric equations. So the coefficients of k terms are 0, 0, 2. These are the components of the direction vector. So we are done with part B. Now we can analyze part C. In part C, we are given the equation in symmetric form. So we can start by writing the general equation of a line in R3 in symmetric form. So in this general equation, x0, y0 and z0 represent the components of position vector of a known point on this line. So as per the given equation, x0 is equal to 1 over 3, y0 is equal to negative 3 over 4, because the sign of 3 over 4 in the equation in the numerator is positive, and z0 is equal to 2 over 5. Now we can write the point. So this is the point that lies on this line. Now we can write the direction vector. In the general equation, A, B and C represent the components of the direction vector. In the given equation, the A value is 1 over 2, so it is the x component of the direction vector. The y component is B, which is equal to negative 1 over 4, and the z component is C, which is equal to 1 over 2. So this is the direction vector of the third given line. So this should be the final answer. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it and subscribe to Homework Help. Thank you very much and have a nice day. Bye.